Chapter 34 begins a series of chapters on ecology. Ecology is the study of the interactions between organisms and their environment. Now, Chapter 34 is an overview of ecology and of the biosphere. In Section 1, it covers the basics of ecology. Again, the study of interactions between organisms and the environment. But ecology exists on several levels. We can study how the individual organism interacts with the environment, or we can study the population level. Population ecology includes things like population size or population demographics or growth or whatever. A community is all of the populations of all of the species interacting with each other in an area. An ecosystem includes the community, but everything else about the environment that's not alive, or abiotic factors. So the ecosystem includes both the living things and the non-living things. The biosphere is everywhere on the planet where life exists, or the sum total of all of Earth's ecosystems. Now, in Section 3, it's an overview of important abiotic factors. Only a few of these are written up here. The rest are in your book and in your notes. For example, solar energy gives us two major things. It's a source of heat, and it's a source of food energy through photosynthesis. Now, of course, the food chain and food energy is an abiotic factor of its own, but heat affects things like climate, weather patterns, the water cycle, temperature, and so forth. Other abiotic factors include available water, soil, mineral content, things like that. Section 4, I just refer to you as reading. It just discusses how populations of organisms and species can adapt to their biotic and abiotic factors of their environment. Now, starting from Section 5, it discusses climate patterns. There's a lot of drawings in your book that you need to refer to, and some of which I've reproduced here on the board. For example, because the sun hits the planet, and the planet has a curved surface, it's a spherical planet, the sun will warm it unevenly. You have more direct sunlight close to the equator, less direct sunlight at the poles. This gives us temperature differences with latitude. Latitude, of course, is the distance between equator and the poles. So it's going to be hot in the equatorial areas and cold in the polar areas because of this uneven warming of the Earth's surface. Now, the Earth is tilted on its axis by an angle of 23.5 degrees, and it revolves around the sun every year. Now, this gives us our temperature differences with the seasons. Now, during June, the sun is directly overhead the Tropic of Cancer, which is 23.5 degrees north latitude. We're having our summer at this time, and the southern hemisphere will be having its winter. 6 months later in December, the winter solstice, the sun is directly overhead 23.5 degrees south latitude. That's the Tropic of Capricorn. So this belt between 23.5 north, the equator, and 23.5 south are the tropics. So the sun is more or less overhead year-round at the tropics, but farther away you have the more temperate zones where you have differences between summer and winter. Now, this picture here coincides with Figure D of your book and Figure C. When the sun hits the equator, it is absorbed by the surface and warms it up, and of course the air right above it will also warm up, and warm air rises. So this depicts rising air. Now, it's going to bring a lot of ocean moisture with it, and then the air is going to cool off, and a lot of that moisture is going to fall as rain. But that air is going to go somewhere. It's going to go back down to the surface around 30 degrees north and south latitude, and then replace the air moving up. But the Earth is spinning underneath the air that is moving over it. See, the Earth is spinning on its axis, giving us what's called the Coriolis effect. The Coriolis effect means that a moving object, whether it's a mass of wind or whatever, is going to be deflected to the right or clockwise in the northern hemisphere, and to the left or counterclockwise in the southern hemisphere. So instead of taking a straight line, we've got these curved paths. These are prevailing wind patterns. In the absence of storms and other disturbances, this is the status quo. Now at the equator, you don't have a lot of wind. It's called the equatorial doldrums. Between 30 and 60 north and south, you have what's called the trade winds. Between 30 and 60 you have the westerlies, and between 60 and 90 you have the polar easterlies. Now, of course, the trade winds are called the trade winds because of old trading vessels and so forth. The sailors knew about this, even if they didn't know why it happened. They knew the patterns. Now, this section also discusses ocean currents, and I've provided this picture here, which is a little more detailed than what you have in your book. Now, the same Coriolis effect is also going to cause the major ocean currents to move in a clockwise pattern because of the wind moving the water and the fact that it's also a moving object. This is the equator, North America, Africa, Europe, Asia over here. So you've got the Atlantic gyre, a large circular current over the North Atlantic. Same thing with the Pacific gyre over the Pacific. Now, in the Gulf, we've got warm water on this side of the Gulf, on the eastern Gulf. You have what's called the loop current. This is not accurately represented in your book, but this loop current goes back into the Atlantic and is referred to here as the Gulf Stream. Now, of course, in the western Gulf where we are, the waters are moving in the opposite way because of the shape of the land masses. Now, this explains a lot of things. If you compare the beaches of southeast Texas with, say, the beaches of Mississippi, Alabama, Florida, they're very different, in part because all this Mississippi sediment moving in our direction from the Mississippi River and other major rivers, not in their direction. Also, from the west coast, you have cool ocean current coming from the north. This is why the climate in Southern California is very different from the climate here, even though we have similar latitudes. I'll stop this first video and we'll continue with the next one.